Unlocking smarter AI insights, how Agentic RAG transforms business decision-making. My name is Jon Culp. I'm the Director of Application Development on the Apollo team. And that team, if you're not familiar, we're working on upgrading the supply chain software. For those who are in the know, I'm also known as the data doctor by some. Thanks for coming. So what we're covering today is LLMs. We'll be talking about RAG, Agentic RAG. All those things combine to form multi-agent networks. We're going to talk about an example of what that could look like, and then we'll get into the question and answer. I'm going to go pretty quick because we're pretty short on time. But the point of this is so that you're looking at these acronyms. By the end of this, you should know what those acronyms mean, how do they work at a high level, and how can they help you? And we're going to do this using non-technical descriptions. So you should walk away not overloaded with technical stuff, but having some understanding of the frameworks, how these things work, how to talk about them, how they might be able to help you. So LLMs, everyone in here is probably familiar with LLMs, right? You've used ChatGPT most likely. There's a UI where you might interact with it through an API. It's got a broad knowledge base. So whoever is the provider of that model has trained it on some specific data and only on that data, right? So you talk to the ChatGPT or whichever service you use, and it only knows about what it's been trained on. You ask it about something outside of that, it's like, I've only been trained through this date. I don't know what you're talking about, right? And the way those things work at a high level is they're predicting text, meaning you give it a prompt and it predicts what the answer should be algorithmically. It may have multiple choices that it might produce, and then it picks what it thinks is the best answer. And that's what it provides. It's not really thinking, right? This isn't broad like AI. This is predictive text really under the hood. So how does that work in terms of interacting? Well, we already just talked through it really. It's pretty simple. You have an LLM you're working with, you submit a prompt to it, processes the prompt, gives you an answer back. Pretty basic, not a lot you can do outside of what it provides to you. So what is RAG? RAG stands for Retrieval-Augmented Generation. And what that basically means is we take that LLM and we give it a way to provide our data to it in some way. And that's basically using like a vector database or JSON documents to get a little bit technical. But what that really means is we're providing a way to feed it some data for some problem. It's very simple. We just feed it into the model through this architecture. So it's going to be able to give you some more specialized answers, right? So if we have some data for servicing or sales, and we want to ask a question using an LLM that gives it context related to those things, we can use this architecture to do that. So in other words, it's tuned for a specific task. How does that work? How do you interact with it? So a user, again, submits a prompt, but now we have this extra thing, an extra action of a search. So we've enabled the process to go look at some piece of data specific to this task, retrieve the data, and then it's going to combine it with your original prompt. So now you have a prompt plus some part place or specific context or whatever data you shared with it based on the question. And so now you have what's called a response agent, which is just an LLM, whatever LLM you've chosen for that task. And it's now has a specific task, which is to process that prompt in that context to provide a more optimal answer than it would have been able to without that extra bit of data. And so this general pattern is called RAG. So when someone says RAG, that's what they're talking about. So now let's get into Agentic RAG. So we take the LLM feature set, we've added the RAG so we can search, and now we're adding Agentic. And what that really means, it's a more advanced, nuanced way to interact with your data. So instead of just for RAG, it's just like a simple search. You provide it the data, it just uses it at face value and tries to produce an answer. Now we have a more autonomous, proactive decision-making tool. So we're introducing engineering into the process, whereas before we were just feeding it data. And so that engineering can do interesting things. It can more intelligently search the data. So it might, instead of going to one repository of data, go to another one, depending on what the question is. So based on the context. It's going to do a broader, a deeper search. It's autonomous, it's proactive, based on how we engineer it, right? So it may do data scoring. So it may evaluate what it retrieved. It may say, this isn't quite right. Like, let's go get some different data. Let's go look somewhere else. And it can resubmit its search. So what does that look like? Once again, we have the prompt. But now we have what's called a retrieval agent. So just as before, we had a, what do we call it? Response agent. So we've introduced a new agent, a retrieval agent, where we've engineered in these features where it has a more capable search functionality. It might look at live data from an app, such as CE. It may need some historical data based on your prompt. So it goes to the data warehouse. Maybe it needs to go to a document repository, like read some contract information. Maybe there's a shared email inbox where you need to obtain some purchase order number from customers. Maybe there's a customer live chat that it needs to plug into. So now you have this more dynamic, broad feature set where you can do just a lot better job of informing the LLM, right? That's what we're trying to do here. At the end of the day, we're applying more advanced search capabilities to get just the best data to really answer what that prompt is asking for. So prompt, again, prompt plus context, the same output as before, just a better context. So now we feed it to the response agent once again, and then the answer is produced. And hopefully it's way better than the previous one because we have all these extra things on top of it. So I keep mentioning this. This is a mixture of engineering and AI, right? This isn't just turn the AI on, point it to data, and it works. There's people involved, right? This isn't. There's no people. Like someone has to know about the business. Some business expert must have been involved with setting this up, right? Because it can't just know. Someone who knows about data and how to add context to it has helped to set this up. So it can produce something amazing, but it needs people, engineers, business people to make it work. Quick example that you're using today, D365 Copilot. You go into Teams and you hit the Copilot icon and you ask a question. It is going and reading your data right now. It'll tell you, right? I don't know if y'all have used it much, but it's going to read SharePoint. It could read your personal Teams chats. So it's doing this. It's a retrieval agent based on the D365 platform. And so it can use the context of your data to answer those questions. But one thing I'll point out though here is that this approach that we're looking at right now is very broad. You can see it's going to a lot of different places. It's trying to handle a lot of different use cases and scenarios. And that's a very difficult problem, which you'll see that manifest in the Copilot, where you ask it a question and it kind of like looks across a bunch of stuff and the answer it gives is sort of in the right direction, but often misses the target. But this is known as Agentic RAG. And so how do we mitigate like that challenge of dealing with such a complex problem? Well, the way you can do that is using a more narrow-tuned Agentic RAG. So we just took that last slide here. We just collapsed it into that box that just says Agentic RAG for sales. And so just to make it simpler. So the same thing, but now we're going to narrowly tune this so that it can just interact with sales. So some salespeople, they've come in and they've said, I know about sales. I know how to tell the AI what to look for. I fed it context about sales. So now that this agent is more trained on what sales means at Park Place or whatever. And so it can do better, it can provide better answers. And so we just feed it sales data. And then we can do the same thing for service. We can do the same thing for finance. And what happens is then you can take those results depending on what the prompt is. You know, maybe it's a broader prompt than just one specific domain. And you can have those talk to each other, whatever those outputs are, right? I have a person here, but it could be, this could be a piece of code. It could be an endpoint. It could be a system. It could be two systems talking to each other. They could be collaborating, right? So the prompt isn't necessarily a human putting it in. It could be systems talking to each other to solve a problem.
Jefferson, James, and who else?
So let's just like consider design decisions, right? So we've talked about narrow-tuned agentic RAG, and we've talked about broad agentic RAG, right? And so you have a narrow end of this, you have a broad end. On the other axis, you have the ability to search data in a shallow way or in a deep way. So when you're broad, usually you're shallow. When you're going deep into the data, maybe it's more of a narrow search. But so when you're shallow and narrow, it's not very useful, right? Like, what is that going to give you? If you're deep and broad, that's going to be very expensive. So trying to solve all the use cases, like the D365, for example, you're not going to get super great results. And if you want to get super great results, it's going to probably be pretty expensive. So there is an optimal set of configurations, right? So you have a narrow window of what you look for, but you're deep in the ability to search through the data because people have put rules in place to allow it to do that. Or you have a broad search, but you can't go very deep. You're shallow, right? And maybe you have two of those things that work together and talk to each other. So these are considerations when you're building these systems. And I say building because there's no turnkey. There are platforms out there that do some of this stuff. You got to configure it. It doesn't just work. All right, so let's make an example here. So I call this the car blueprint generator. So what we're going to do is we're going to say, this is some app we've written. It takes the input from a person. You tell it, hey, I want to design this kind of car. It's going to output a blueprint, maybe a 3D render, maybe the parts you got to buy to build it, and like all the instructions to do that, right? So how would you do that using this approach? So I have this user here. They say, design a high-performance sports car that looks like a server rack. What does that mean? Makes no sense. I don't know, but it seemed Park Place specific, so I put that in there. So let's say, so let's collapse some of these ideas even higher level than we've looked at. We're just going to encapsulate all these things into what we just call an agent, right? So all the agentic RAG, all those steps it's doing, collecting the data, feeding it back to an LLM to give a response. Now it's just an agent. So we have a project manager agent. And so he's going to take the user requirements and he's going to coordinate with other agents. And then you have an engineer agent, and that agent is going to take the prompt, take the user requirements that have been designed by the project manager. It's going to create a rough design. It's going to create calculations. And then that agent's going to work with agents for specialty design, right? So it's an agent to design a body, to design an interior, to design the powertrain, the chassis. And then with their results go back to the engineer, and then the engineer talks to the QA agent who does tests, he does validations, right? And then you have a documentation agent who is going to take all that stuff. Everything's been QA'd. Everyone agrees that the thing that we're building here seems to be what the user's asking for. So let's put it into a format to then give it back to the user. He's going to produce the blueprints, all the artifacts we talked about, the 3D render, the part list. He's going to do the cost estimation. Send it back to the project manager. Project manager talks to the user, says, hey, here it is. This is what you asked for, right? And hopefully they're smiling and they run away and they pay their $5 and everyone's happy. So that's an example. Hopefully kind of makes sense. So I've just like walked you through from LLM to a RAG to agentic RAG to basically showing you how you would put that into a multi-agent network, right? Non-technical. Hopefully it helps. So then we produce this. This is obviously using just generative AI. It doesn't really make any sense. I love that it put a like floor fans. Computer fans as floor fans. Yeah, so that's basically it. I wanted to kind of touch on it before, but one of the main points here, a couple main points, is that people are still involved, right? Like AI is going to enable you in a lot of ways to be smarter, faster, automate some things. But to pull all those things together, you still need people, you need engineers, you need business experts. So I think there were some comments and some